Today, so today we have one question from 2022 September Csir net exam. The question is, let R be a field of real number, okay? So, and V be the space of all real polynomial, real polynomial of degree at most one. That has to be noticed here, and the bilinear form is defined in this way. So, so the space is nothing but the polynomial of degree at most n. So one can write it as p1x, p1r, the polynomial of degree at most 1. And on this space we have defined inner product as integration of 0 to 1 fx to gx dx, right? This is the inner product defining on this space. So what are the options here? There is nothing much more on the question, so everything is there on the options. So for option A, for all non-zero real number a, b, there exists a real number c such that these two vectors are orthogonal to each other. So what do you mean by orthogonal? The vector a and g are orthogonal if on inner product space, of course on inner product space, inner product of f and g equal to 0, right? So for here we have given ax plus b, right? So for this ax plus b we have to find, we have to give the answer that whether there exists some x plus c which is arise by the help of c, right? So we have initially ax plus b. For this x plus b, whether there exists x plus c so that these two vectors are orthogonal to each other. So let us assume there exists x plus c at instance, okay? So ax plus b, x plus c equal to 0, equal to 0 imply integration of 0 to 1 ax plus b, x plus c equal to 0, right? So yeah, so once we calculate it and then integrate it, we'll have a by 3 plus b plus c over b plus ca, right? Over 2, plus bc equal to 0. So here if we take common, b plus a over 2 equals to minus of a by 3 plus b by 2. So from here we'll have 2a plus 3b by 2b plus a times 3. So of course we can see that this might 0, right? A plus 2b may 0 at some point. So if you suppose some element, let's say x, if we have a equal to minus 2, right? So let's say it is minus 2x and plus 1. What is a here actually? A equal to minus 2 and b equals to 1. So for that case there does not exist any such c, so that x plus c is perpendicular or orthogonal to ax plus b. So this option is wrong, right? So similarly we can go with for option b. What is that question saying? We have to find for x plus b, x plus c, so that these two vectors will be 0, orthogonal to each other. What does it mean? 0 to 1 x square plus b plus c whole into x plus bc equal to 0. So this implies 1 over 2, this will be 1 over 3, this will be b plus c over 2 plus bc equal to 0. Which implies if we take common c, this will be b plus 1 over 2 equals 1/3 plus b over 2. So C is nothing but 3 times 2b plus 1, and here will be 3b plus 2, right? So similarly you can see same thing here. Actually they're on the left and the below sorry, these things, the numerator denominator is actually what, 2b plus 1, that may be 0 for some b, right? If you choose b to be minus half, for that case it will be 0. So b option is also same, in the same way it is also wrong. So let's go for the option C. What option is C? So we have similar way, ax plus b and cx plus c orthogonal. So ax plus b and x plus c, I think, yeah, x plus c, 0 to 1, ax square plus b plus ac all into x plus bc, things equal to 0. This implies a over 3 plus b plus ac over 2 plus bc equal to 0. So what is the question? Let's read once more. For all positive integer, positive, this is positive real number c, there exist infinitely many real number a, b such that ax plus b and x plus c are orthogonal to each other. So mind it, this a c is positive. So I mean this is given, right? This x plus c is given. For this x plus c we have to find whether there exists x plus b, such a x plus b, so that these two are orthogonal to each other. So yeah, then 2a plus 3b plus ac plus 6bc equal to 0. So this is actually, I mean, a and b are the solution of the equation 2x plus 3y plus xc plus 6 y c equal to 0. So it's a linear equation, right? And of course it will have a infinite solution. So how many solutions are there? How many solutions are there? It is infinite. Why? Because on a line, how many solutions are there? These all points are actually solution for this equation. I mean all point a and b will be such points so that these two vectors are going to be orthogonal to each other, right? So let's go for the last one. So here there exist infinitely many real numbers, so it is true, right? The last one is saying the two vectors are non-zero real number b, there are infinitely many real numbers c such that this is involves the vector b and x plus c is orthogonal to each other, where b is non-zero only, belongs to real number. So b and x plus c, so this is given, right? So equal to 0 imply b times integration 0 to 1 x plus c dx equal to 0, which imply b into x square by 2, the replace limit, it will be half plus c equal to 0. So since b is non-zero, so c must be minus half, right? But question, there are infinitely many real numbers c, so that it is 1. So they are claiming that there are such infinitely many c, which is not true, so it will be false. So the right answer is only question ID 1194, that is option C. Okay, thank you.